I have to ask, has humanity fundamentally misunderstood the center of the universe? I mean, for centuries, we looked up at the night sky and comfortably placed ourselves right at the very heart of creation. We were the main event. But as our scientific instruments have grown sharper, well, our cosmic ego has taken a bit of a beating. It seems like every single time we look further into the dark, our own significance just shrinks. So are we the main character of reality, or are we just a microscopic speck in an infinitely expanding ocean? Okay, let's dive into this. Welcome to the ultimate zoom out, from our local solar system all the way to the edges of the multiverse. Let's start by anchoring ourselves right here in our own solar system. Now, you probably remember the great Pluto debate of 2006. People were pretty upset, but the science behind it is actually a perfect demonstration of gravitational hierarchy. To actually make the cut as a true planet, a celestial body has to pull off something astronomers call clearing the neighborhood. Basically, in the end stages of forming, a body has to become so gravitationally dominant that it essentially sweeps its orbital zone completely clean of any other bodies of comparable size. It either absorbs them or it violently flings them away. It's kind of like being the ultimate cosmic snowplow. Now, think about the mathematical reality behind that definition, because what's really interesting here is the sheer orders of magnitude in difference. Astronomers use specific formulas, like Margot's pi and Soter's mu, to actually measure this gravitational dominance. For a true heavyweight planet like Jupiter, Margot's pi is over 40,000. But for Pluto and Ceres, it's a tiny, tiny fraction of 1. So you see, it's not a close call at all. True planets are mathematically and undeniably the undisputed bosses of their orbital lanes. But hey, just because our major planets have cleared their lanes doesn't mean our solar system is empty. Not even close. In fact, our localized cosmic backyard is incredibly crowded. Case in point, the International Astronomical Union's Minor Planet Center recently confirmed a massive batch of new moons orbiting Saturn. The new total, a staggering 285 moons. No way, right? These are mostly tiny satellites, maybe 1 to 2 kilometers across, all completely caught in Saturn's immense gravitational web. And following right on Saturn's heels, Jupiter isn't slacking either. Its confirmed moon count now sits at 101. So when we talk about just a single planetary system in our neighborhood, we are literally talking about hundreds of celestial bodies dancing around a gas giant. It really puts the absolute complexity of our immediate gravitational neighborhood into perspective. Okay, so we've zoomed out to the edges of our solar system, which is all anchored by our sun. But we have to remember a somewhat humbling fact. Our sun is incredibly average. I mean, it's a completely standard issue, middle-of-the-road yellow dwarf. So that begs the question, if our sun is just an average star, what does a true cosmic giant actually look like? Well, get ready to feel very, very small. And this brilliantly illustrates the sheer, terrifying scale of massive stars. It's almost hard to comprehend. If we set our sun as a baseline of just one solar radius, it completely, utterly disappears when you stack it up against behemoths like WOHG 64, which is 1,540 times wider than our sun. And then there is the absolute monster, UY Scuti. It's the largest star we've observed so far, coming in at a massive 1,708 solar radii. To give you a raw number, its radius is 1.2 billion kilometers. Now, because numbers in the billions of kilometers are pretty much completely incomprehensible to the human brain, let's anchor these stellar sizes to a relatable concept, the speed of light. If you were traveling at the absolute speed limit of the universe, which is nearly 300,000 kilometers per second, it would take you about 14.5 seconds to fly all the way around our sun. Pretty quick, right? But if you tried to fly around the red supergiant VY Canis Majoris at that exact same speed, it would take you 6 solid hours. 6 hours at the speed of light. That is the true awe-inspiring scale of a cosmic giant. So we've seen that our planet is just a speck compared to our sun, and our sun is basically a speck compared to the giant stars of the cosmos. But what happens when we zoom out even further? What happens when we push past individual stars entirely and look at our whole galactic neighborhood? We live in the Milky Way, a vast spiral galaxy roughly 100,000 light-years across, containing somewhere between 100 and 400 billion stars. That sounds massive, right? But take a look at our closest major neighbor, the Andromeda galaxy. Andromeda is about 2.5 million light-years away, and it absolutely dwarfs us. It spans 220,000 light-years and holds roughly 1 trillion stars. These two titans completely dominate our local group of galaxies, separated by millions of years of seemingly empty space. But spoiler alert, they aren't going to stay separated forever.
So the crucial point is that this immense distance is actively shrinking. Gravity is pulling these two galactic behemoths together right now. Andromeda is hurtling toward us at 110 kilometers per second. Fast forward a few billion years, and their massive gravitational fields will begin to warp and twist their shapes, throwing out huge tidal tails of gas and stars. And finally, in about 4 billion years, they will undergo a massive merger. They'll settle into a single, unimaginably giant elliptical galaxy that astronomers have playfully nicknamed Milkomeda.
Okay, galaxies colliding, billions of stars dancing around, this is all happening inside our observable universe. And the universe is, by definition, everything we can ever see or interact with, right? But theoretical physicists and cosmologists have started asking a deeply unsettling yet fascinating question. If our universe is just one expanding zone, what lies beyond those cosmic boundaries? Well, to understand what might be out there, we have to look at the theory of eternal inflation. According to this framework, just a tiny fraction of a second after the initial Big Bang, space underwent a violently rapid exponential expansion. We're talking about increasing in volume by a factor of 10 to the 78th power. But quantum mechanics ensures randomness. This inflation didn't just stop everywhere all at once. In localized pockets, the expansion decayed and stopped, leaving behind a bubble universe. And our universe is just one of those bubbles. Meanwhile, the space between these bubbles just continues to expand exponentially forever, continually stopping in random places to form countless new bubble universes. It's like an endless cosmic boiling pot. And because the exact conditions when that inflation stops can vary drastically, these other bubble universes wouldn't necessarily look anything like ours. The overarching laws of the multiverse might dictate exactly how bubbles form, sure, but the localized laws of physics inside them, they could be completely alien. The physics suggests you could have universes with fundamentally different masses for electrons. You could have varying fine structure constants that completely change the electromagnetic force. You could even easily have completely dark bubble universes where a star never, ever had the chance to form.
Let's move to and see how this builds on a very persistent historical trend. Just think about humanity's track record for a second. Back in 1543, Copernicus finally proved the Earth was not the center of the universe. Then in 1911, Harlow Shapley proved that our sun was nowhere near the center of our galaxy. And in 1924, Edwin Hubble proved that our Milky Way galaxy wasn't the entire universe, but just one of billions. Every single major leap in astronomy has basically been a downgrade to our cosmic significance.
Which brings us to the absolutely profound realization implied by eternal inflation. The event we call the Big Bang, which happened 13.8 billion years ago, it might not have been the beginning of everything. It was simply our Big Bang, not the Big Bang. Our entire observable universe, with its billions of galaxies and trillions of stars, might just be a tiny, insignificant blip of a bubble inside a vast, eternally expanding ocean of other universes. We started this explainer looking at the rocky planets in our local neighborhood, and we have zoomed out past giant stars, past colliding galaxies, and past the very edges of our own universe into an infinite, self-replicating multiverse. So I'll leave you with this to chew on. In an exponentially growing ocean of universes, just how insignificant are we? Or perhaps, is it a miracle that we are here at all, with the minds to even comprehend our tiny place in the endless dark? Keep wondering, keep looking up, and thank you so much for exploring with us.